I'm going to be doing problem 27 from chapter 10. So we have a car tire. So model is having two sidewalls of uniform thickness of 0.635 centimeters and tread wall of uniform thickness 2.50 centimeters and width 20 centimeters. So we have a diagram of our tire. So the radius of this inner part is 0.165 meters. The radius to right before the tread is 0.305 meters. And here we'll draw the tread around this. And then the radius all the way out to the tread is 0.33 meters. The tread's width is 0.2 meters, and then the width of the sidewalls is 0.00635 meters. Okay, assume the rubber has uniform density equal to 1.10 times 10 to the third kilogram per meter squared. Find the moment of inertia about an axis through its center. Okay, so we can treat this as having three different parts, this two sidewalls and the tread, and then we can add them all together to find the total moment of inertia of the tire. So first we'll find the moment of inertia of the tread, and we can treat it as being a hollow cylinder, and the moment of inertia of a hollow cylinder is 1/2 m radius 1 squared plus radius 2 squared. Okay, so taking that 1/2 mass radius 1 squared plus radius 2 squared. So we don't have the mass of the tire, we just have the density, and density is mass over volume, therefore mass is density times volume. So 1/2 density volume radius 1 squared radius 2 squared. Okay, so the volume of this hollow cylinder, 1/2, so density, and then volume is pi radius 2 squared minus radius 1 squared h times the radius 1 squared plus radius 2 squared. Okay, 1/2, 1.10 times 10 to the third kilogram per meter squared pi. So for the tread, the greater radius is 0.33 meters, and the smaller radius is 0.305 meters here. So 0.33 meters squared minus 0.305 meters squared times the height of the sidewall, or the width of it, which is wait, what am I doing? The tread. The height is 0.2 meters. Okay, there we go. And then multiplied by r1 squared plus r2 squared. Okay, calculate that all out, and it will come out to 1.1 kilogram meter squared. Okay, so now we have the tread done. Next, we'll be doing the sidewall, the moment of inertia of the sidewall. So, it's the same concept as the tread. We'll treat it as a hollow cylinder. So moment of inertia of a hollow cylinder, 1/2 m radius 1 squared plus radius 2 squared. Same thing as before, we don't have the mass, so density times volume, r1 squared, r2 squared. 1/2 density and the volume is the same. Pi r2 squared minus r1 squared. Height r1 squared plus r2 squared. And plug in 1/2, 1.1 is 10 to the third kilogram meter cubed pi. And okay, so the larger radius for the sidewall is 0.305 meters here, and the smaller radius is 0.165 meters here. So it's the inner area right here. So taking that, the larger radius, 0.305 meters squared minus 0.165 meters squared times the height, which is, or also the width, which we found earlier to be 0.00635 meters, and then multiplied by r1 squared plus r2 squared, 0.305 meters squared plus 0.165 meters squared. Okay, calculate that all out, and 8.68 times 10 - 2 kilogram meter squared. Okay, so we said earlier that the moment of inertia of the tire would be, we'd be adding up the two sidewalls and the tread. So 2 moment of inertia of the sidewall plus moment of inertia of the tread, 2 add that all together, and 1.28 times nothing, 1.28 kilogram meter squared. So that's the moment of inertia of the tire.